When you look at a photograph of Earth from space, one thing becomes immediately clear. Our planet is blue. Water covers more than 70% of Earth's surface, which is why it's easy to assume that water is one resource we will never run out of. Hi, I'm Tom, and welcome. I know you've been waiting for this, so let's get started. In total, Earth holds about 1.26 billion cubic kilometers of water. That is an almost unimaginable amount. And importantly, this water never really leaves the planet. It constantly moves through what we call the water cycle, evaporating from oceans, forming clouds, falling back as rain or snow, seeping into the ground, flowing through rivers, and eventually returning to the sea. From this perspective, it might seem like water is a perfectly renewable resource, something we don't really need to worry about. But that assumption couldn't be more wrong, because while Earth has a lot of water, almost all of it is unusable for humans. About 97% of all water on Earth is saltwater, locked away in oceans. The remaining 3% is freshwater, but even that small fraction is mostly inaccessible. Over 2/3 of Earth's freshwater is frozen in glaciers and polar ice caps. When you break it all down, less than 1% of Earth's water is actually available for human use. This includes rivers, lakes, reservoirs, and, most importantly, groundwater. And this tiny fraction is disappearing faster than we realize. For decades, we've lived with the illusion that water will always be there. Turn the tap, and it flows. No questions asked. But in recent years, cracks in that illusion have begun to show. In 2018, Cape Town, South Africa, came dangerously close to what officials called Day Zero. Day Zero was the day when the city's taps would be turned off completely. No running water in homes. No clear timeline for when it would return. Cape Town avoided Day Zero by a matter of weeks. The only reason it didn't happen was because of extreme restrictions, including a daily limit of 50 liters of water per person. For comparison, the average person in developed countries often uses more than twice that amount every single day. The crisis was caused by years of drought, rapid population growth, and outdated infrastructure. And Cape Town is far from alone. Another striking example is Mexico City, one of the largest metropolitan areas in the world. Much of its water comes from underground aquifers, massive reservoirs beneath the surface. The problem is that groundwater refills incredibly slowly, and Mexico City is pumping it out far faster than nature can replace it. As a result, parts of the city are sinking by several centimeters every year. Buildings crack, roads warp, entire neighborhoods slowly collapse downward as the ground beneath them loses its structural support. And this isn't just a local problem. NASA used satellite data to analyze 37 of the world's largest groundwater systems. The findings were alarming. 21 of them are being depleted at an unsustainable rate. The most extreme case is found on the Arabian Peninsula, where millions of people depend on what's known as fossil water, ancient groundwater that accumulated thousands of years ago and does not naturally recharge. Once it's gone forever. More than 60 million people rely on this water. Now, add the future into the equation. Earth's population continues to grow. Developing countries are industrializing. Living standards are rising. And with that comes an explosion in water demand. Experts estimate that global water demand will increase by around 50% by the year 2050. And as if that wasn't enough, there's another force accelerating the crisis: climate change. Climate change doesn't just mean higher temperatures, it reshapes rainfall patterns across the planet. Wet regions are expected to become wetter, dry regions even drier. Some studies suggest that up to 40% of the world's freshwater resources could be severely affected or depleted within the next century. So where does all this water actually go? Many people assume household use is the main culprit: showers, washing machines, toilets. And while that does matter, it's only part of the story. Industry consumes massive amounts of water: power plants, factories, mining operations. But by far the largest share goes to agriculture. Around 70% of all fresh water used globally goes toward growing food. And this is where things get really surprising. Producing just 1 kilogram of coffee requires roughly 21,000 liters of water. A single average hamburger can require around 5,000 liters. Even something as simple as a cotton t-shirt may represent over 2,500 liters of water. This hidden consumption is known as virtual water. Water we never see but use every day. So the big question remains, when will Earth run out of water? The short answer is it won't, at least not completely. Water as a substance isn't disappearing from the planet, but the long answer is far more unsettling. What we are running out of is cheap, accessible, clean fresh water. And once that disappears, entire regions could face severe shortages, forced migration, economic collapse, and even conflict. Water scarcity isn't a future problem. In many places, it's already happening. The good news is that solutions exist. Some countries are already proving that change is possible. Denmark, for example, has reduced its water consumption by more than 40% since the 1980s. They achieved this through higher water prices, efficient technologies, public awareness, and major investments in infrastructure to prevent water loss from leaking pipes. And while large-scale solutions matter, individual actions still play a role. Shorter showers, turning off the tap when it's not needed, running dishwashers and washing machines only when full. Reducing food waste. These small choices multiplied by millions of people add up. Water is not an infinite resource. We've simply treated it like one. Producing food consumes massive amounts of water, often hidden from our daily perception. Desalination plants are increasingly used to turn seawater into drinking water. Saudi Arabia, the UAE, and Israel rely heavily on this technology. Similarly, wastewater recycling treats used water for irrigation, industry, or even human consumption, creating a sustainable water loop. On an individual level, simple actions make a real difference. Shorter showers, turning off taps while brushing teeth, running washing machines and dishwashers only when full, and reducing food waste all save water. Millions of people making these small changes can collectively preserve vast quantities of fresh water. Environmental impacts are equally crucial. Drying rivers, vanishing wetlands, and collapsing fisheries show that water scarcity threatens entire ecosystems. Protecting water means protecting life itself. Emerging technologies could further help. Smart irrigation, cloud seeding, capturing water from the atmosphere, and even transporting water via pipelines or ships. Yet, technology alone cannot solve the problem. Global cooperation, smart policy, and responsible personal use are essential. And the question is no longer whether water scarcity will affect us, but how soon and how prepared we are when it does. If you enjoyed this documentary, don't forget to like, subscribe, and leave a comment. Thanks for watching.